Hello everyone, my name is Jennifer Villareale, a PhD candidate at Drexel University. On behalf of my fellow co-authors, I'll be presenting the paper, I Want to See How Smart This AI Really Is, Player Mental Model Development of an Adversarial AI Player. Game designers and researchers have been increasingly exploring a variety of AI approaches in computer games. From procedural content generation to intelligent non-player characters, game designers are producing many novel gameplay experiences. And in particular, some AI-based games are even foregrounding these systems in the game experience, where players may notice and reason about the AI during gameplay. So there are many games that allow players to become aware of and playfully interact with these systems, and in turn they're constructing mental models that may be more or less accurate. Understanding players' mental models and designing the gameplay respectively has shown to be an important lens when designing the player experience. However, game designers face the difficult challenge of anticipating how players may model these AI agents during gameplay and how they may change with experience. To increase our understanding, we conducted a qualitative study to examine how a pair of players develop their mental models of an adversarial AI player. We conducted 10 gameplay sessions in which two players worked together to defeat the AI in the game iNNk. iNNk is a web-based multiplayer drawing game where two or more people play together against a neural network. To win the game, players have to communicate a secret code word to each other through drawings without being deciphered by the neural network. There are two roles in the game, the sketcher and the guesser. The sketcher needs to draw the code word in such a way that a human guesser may correctly guess the word before the neural network. Each session was audio and video recorded with the player's permission and included a pre-gameplay survey, which gathered players' self-reported understanding of how they think neural networks recognize images. Then 3 matches of the game iNNk, where players were instructed to think aloud and to find different ways to beat the AI. And finally, a short interview after each match designed to elicit information about how they thought the AI worked. For our data analysis, we leveraged the recordings to examine the development process as a whole. Specifically, we utilized the gameplay data, so what the player does with the AI, in this case it's the drawings, and the feedback the player receives, which are the AI's guesses. We also used the think aloud data to observe the differences in how players go about developing their mental models. First, we prepared the data by visualizing it into a diagram. This screenshot to the right is an example diagram that visualizes the data for Session 2's first match. The diagram showcases each player's drawing for each round of gameplay, and the AI's guesses, the code word, and also the utterances made by both players during gameplay, and after during the interview. Next, using each round of gameplay as the unit of analysis, we coded each round to map the progression of development across each match. We coded for AI concepts, which we refer to as verbalized notions made by participants about the AI, that includes a hypothesis or a conclusion regarding how it works. We also referenced existing cognitive development and HCI literature to code the focus of the development, which refers to if players build their mental model from gameplay observations, which is bottom-up, or if they tap into their existing knowledge, which is top-down. And then we coded for mental activities through the lens of assimilation and accommodation, which refers to if and when the group changed their mental model, either by assimilating an AI concept in which they added or expanded on a concept during gameplay, or if they changed a concept due to a discrepancy to account for new information, which we refer to as accommodation. Finally, for Phase 2, we coded the pair of players' mental model development by reviewing the progression of mental model activities and AI concepts for each session as a whole. All of these steps led to establishing our codebook of mental model development, which I will present next. For the resulting codebook, we first considered the focus of development and felt that the codes derived from prior work were sufficient. Either players try to beat the AI player based on an existing model, or attend to the game experience and base construction on what they observe. Our analysis found that 6 groups developed their mental model by evoking prior knowledge. So for example, one group utilized their prior knowledge about databases and concluded that the AI recognizes patterns and compares it to a database of images to make its guess. In contrast, 4 groups developed their mental model by attending to the gameplay experience. For example, one group was remarking on observations of the AI's guesses and concluded that the AI picks up on shapes of the drawing. Next, we considered how change happens through the lens of assimilation and accommodation. We refer to these codes as development styles. For assimilation, two main codes were derived from examining how groups assimilated AI concepts. We found that players either developed their mental model systematically or reactively. 6 groups were coded as using a systematic development style in which they built on previous observations, so this style continued to build on and utilize their mental model. 4 groups were coded as using a reactive style in which they did not build on previous observations. Instead, they attended to the moment and integrated new information independent of what was previously observed. For accommodation, 3 codes were derived from examining what players said and did in response to a discrepancy, in which they changed their mental model to account for new information. We observed this occur through comparisons. When processing a change, players would compare the gameplay observation to other systems or another system functionality, previous rounds of gameplay, or to themselves, in which they would compare how humans and the AI might perceive gameplay. Groups coded as using a systematic style process a change in their mental model by comparing to gameplay or comparing to themselves. Groups coded as using a reactive style process a change by comparing to themselves or comparing to other systems. After establishing the codebook and reviewing the development of the 10 sessions, we found that the codes for the focus and the style of development best described how players are developing their mental model. Therefore, we recognize the first dominant dimension of the framework as focus and the second dominant dimension as style. We further describe the second dimension with how players are processing a change through those comparisons, which we describe in the paper. We organize each session based on these dimensions, which is visualized in the figure to the right. We can see here that the majority of the groups used a top-down focus and systematic style, while the other groups were evenly distributed across the other dimensions. We offer these results as a preliminary framework to help game designers anticipate how players may go about making sense of these AI agents as they interact with it. Finally, I encourage you to read our paper, as it offers how our framework can be extended and generalized to the design or the evaluation of other similar AI-based games.